Hi folks, this Algebra 2 lesson is take us a little bit at solving systems of linear equations in three variables, okay? Three variables. A linear equation in three variables has three variables, x, y, and z, okay? The a, b, and c and d are just numbers, okay? So ax plus by plus cz equals d, okay? And the ordered pairs are just x, y, z, so whatever we get for x, y, and z. These graph planes, they don't graph lines, you guys, they graph planes, and don't worry, we won't have to graph these yet. And so your solution is just the ordered triplet. I said that twice. I guess I didn't need to. So sometimes your planes will intersect, hopefully, in one point right there. And when they do, it's going to have one solution right there. Okay, these figures are on page 178 in my textbook. Sometimes the planes intersect in this manner where there's infinitely many points that they all share, and they're all on this line. There's a point there, there's a point there, a point there, a point there, a point there. Infinitely many points right there. Sometimes all three planes don't intersect in the same spot, and there's three different examples where they don't intersect, and you're going to get no solutions on those ones. That's when you run into something funky like 0 equals 2 or something like that. When you get a solution like this, you guys, you're going to get like 8x plus 5y equals 8x plus 5y. You get the same thing on both sides of the equal sign. So that's when there's infinitely many solutions. All right, and I have an example of two of those anyway. So steps to solve systems of equations in three variables. So what you do is there's going to be three equations. I like to label them 1, 2, and 3. And then I take any pair of equations, so either 1 and 2 or 1 and 3 or 2 and 3, any pair, and eliminate one variable. And then when I do that, then I'll call that equation number 4. And then take another pair of equations, and it has to be a different pair. So and eliminate the same variable and call that equation 5. And then you put 4 and 5 together and use your algebra skills to solve. So you'd be back in your Algebra 1 class. So whatever you get, substitute those solutions. So probably x and y, that's what I have on these ones. So or x and z or y and z, whatever two solutions you did, into one of the first original equations, and that'll get you your third variable. Here's an example right here. Okay, so here's three equations. Now you guys want to pause this. I don't have time to pause it here. I'm going to label them equations 1, 2, and 3. And then I'm going to just kind of scan over these. Here's a 2x, a 6x, and a negative 4x. Well, I can make all these 12x's if I wanted to. Here's a 2y, a 4y, and a 1y. I like the 1y right there. I don't care if it's negative 1y or positive 1y. Because I can make this 1y a multiple of 4, a multiple of 2. So that's what I'm going to do is I'm going to target the y's right here. I'm going to take, I forgot what I did here. Yeah, I'm going to eliminate the y. I'm going to take equation 1, and if I take this equation 1 right here, multiply it by 4, I get a negative 4y that'll cancel out with that positive 4y. So if I take this, multiply it by negative 4 all the way through, and just add it together with equation 2 right here, I'm at this stage right here. So when I add them together, the negative 4y and positive 4y cancel out, and I'm left with an equation with two variables right there. So I call this equation number 4. Okay, so now I'm going to take another equation. I'm going to take equation 3 this time. This one right here, I multiply it times 2, because when I multiply it by 2, it's going to make it a negative 4y again. And I can just add that with equation 2 right there. So take equation 3 times 2, and I get that. And then there's equation 2 right there. Add those together. And when you do that, there's equation number 5. Okay, so now I'm going to take equation number 4 and 5 and use my Algebra 1 skills to solve for those guys right there. Can you see if I multiply this by 7, I'll get a negative 14x. So times 7 times 7 times 7, and that's going to get me those guys right there. Now I can add those guys together, and I get 54z equals 54, so z equals 1. So substitute z equal 1 into, I put it into this one right there. And then I get x equals negative 3. So now I have x equals negative 3, z equals 1, and I'm going to go back to one of the original equations to get y. Okay, so I put it in the top equation, the first one right there. So it was 2x minus y plus 6z equals negative 4, and I put in x equals negative 3 for x, and put in z equals 1 for z, and then solve those guys, and you get y equals 4. So your ordered triplet is x, y, z. There it is, negative 3, 4, 1. Let's try another one. Okay, all right, so there's one. I'm going to label them equation 1, 2, and 3. Okay, now I took equation 1 and equation 3 because, again, I should have picked a different problem because I get rid of y again. I should have picked one where we got rid of x first, but I didn't. So when I add those together, I get 3x plus 3z equals 9. Now I like to divide that by 3 because I want smaller numbers. I don't want to deal with the big numbers. So I took that equation and divided everything by 3. And that's what I called equation 4. Okay, so now I took equation number 3 and multiplied it by 3, because then it'll cancel out with that 3 right there. Okay, when I do that, I get that right there. Okay, now what I'm going to do is take this equation right here, this is equation 5, multiply it by -9, that way it'll cancel out the +9, and check out what happens, you guys. I get 0 equals 2. Well, 0 doesn't equal 2, so that's where you get a no solution right there. So it's one of those plain ones right there. Okay, one more, you guys. Alright, so there's equation 1, 2, and 3. Okay, and I took equation 1 and equation 2 and added them together. Notice the two x's right here, the y's cancel, the z's cancel, so x equals 6 right there, 2x equals 12. Okay, and then I took equation 2 and equation 3, added those together, and got, notice those are all divisible by 5, so I divided them by 5, got x plus y equals z, plug in x equals 6 right there. Alright, and you get y equals 4. So substitute that into whichever equation you want to, and I get z equals 0 on that. Okay, you would get an infinitely many solutions if I would have got like 5x equals 5x, or 8x plus y equals 8x plus y, or something like that, something that agrees right there. Okay, if you're in my Algebra 2 class, there would be your homework right there.